Hello, this is your instructor Kumran here. Continuing on what is data science, we are going to be talking about what is learning. In data science parlance, what is learning, and which is discovering knowledge from data. The first thing we want to note is what is a relationship. Relationship again forms one of the foundations of data science, and when we talk about relationships, we talk about relationships between attributes. So attributes in a data set exhibit relationships. You have an observation, you have a set of observations in a data set, and the attributes that you see in these observations exhibit what are called relationships. Relationships model the real world and have a logical explanation. When we say model the real world, relationships are basically something that is happening in the real world. It is not something out of the blue that you would see something in the data set. The data set, whatever data you have, the relationship it shows is something that exists in the real world. For example, age and blood pressure levels. The relationship between them is that as age goes up, the propensity for higher blood pressure keeps going up. The higher your age, the higher might be your blood pressure levels. And there is always a logical explanation associated with it. And the reason in the medical field they say is that if you have more weight, obviously you will have more fat, you will have more clogged arteries, which will lead to higher blood pressure. So there is something that's happening in the real world and there is a logical explanation for it. An explanation is a very important part of data science. When you see a relationship, you should be able to explain why it is happening, because that's when we can say whether the relationship is incidental or it happened by chance, or that it does exist something like that. For attributes A and B, the relationship can be like when A occurs, B also occurs. You have two attributes A and B. So whenever A is occurring, B is also occurring. Let's say whenever a sale happens, something else also happens. Like when a sale of a cell phone happens, a sale of a cell phone cover also happens. So things that happen together. When A occurs, B does not occur. This is like the negative relationship, when A and B are kind of mutually exclusive. Mutual exclusiveness is again a kind of relationship. The third one is when A goes up, B also goes up. So that's another type of relationship. And when A increases, B decreases. So that's like another negative relationship. So when you have two attributes, the values of these attributes, the values that are seen in these attributes show any of these kind of relationship. Not all entities will exhibit relationship. There will be always some entities where you will see some relationships. Some entities don't exhibit any relationship at all. Our goal in learning is to look for entities which together exhibit some form of relationship. And relationships can involve multiple attributes too, like when A is present and B increases, C will decrease. So multiple attributes together might exhibit some form of a relationship. So this is a kind of an overview of what relationships are. Now let us go and see what are some of the examples for relationships. Like when you take a customer, as age goes up, spending capacity goes up. So there is a relationship between age and revenue from the customer. So in age goes up, spending capacity goes up. There is a logical explanation that as age goes up, possibly the person is making more money, so their spending capacity is also high. Now when we talk about relationships in data science, these are not very concrete relationships. It's not really like a formula that they happen all the time. Now those kind of things, like 100% kind of a relationship is good, but what we see here is overall, in general kind of relationship. Like when age goes up, spending capacity goes up. Not all customers, not all old customers are going to spend more, but most of them. That is what we talk about as a relationship. The other one is urban customers buy more internet bandwidth. There is a relationship between the location of the customer and the bandwidth purchased by the customer. Again, possibly because they are doing more browsing. When you look at a patient, again, there are a lot of relationships you can see, like older patients have more prevalence of diabetes. There is a relationship between age and disease level. Overweight patients typically have higher cholesterol levels. There is a relationship between weight and HDL. Again, there are scientific reasons why these things happen. You take a car, there is a relationship between the number of cylinders and the mileage it gives. So more the cylinders, the less the mileage, because there is more burning happening when there are more cylinders. Sports cars have higher insurance rates. Now, this is not a technical relationship, but you will see this as a business relationship. Like a sports car, whenever the car is of a type a sports car, its insurance rates are typically higher. So there is a relationship between the type of the car and the insurance rates. Some more things about relationships. One of the things you want to bother about is when you see a relationship between two attributes, is the relationship consistent or is it incidental? Now, relationships can also be set as patterns. Patterns is what you see in data, patterns of behavior. Sometimes the pattern of behavior might be consistent because it happens all the time. You can repeatedly, when it happens all the time, you can actually predict such a behavior in the future. Whereas there could be incidental patterns, incidental relationships also. When you say incidental, it just happened by chance. There might be no logical explanation for an incidental behavior or an incidental pattern. So whenever you see a relationship, it is very important for you to make sure that the relationship is consistent versus incidental. Consistent relationships are what you need for data science. Relationships are also called as correlations. That is the technical term that you will see being used. So correlation between two entities or two attributes is what you see as when A goes up and B goes up, A goes up and B goes down. That is what you call correlation. So correlation is the technical mathematical term you talk about when you talk about relationship. And finally, people talk about signals and noise when it comes to data science. Signals are nothing but consistent patterns or consistent relationships you see in data. Noise is incidental patterns or incidental relationships you see in data. So if you have been hearing about these terms, signal and noise, they are nothing but relationships that are meaningful versus relationships that happen by chance, which are not predictable, which are just incidental. So that is the difference between signals and noise. Now comes what is learning. We keep talking about machine learning and this learning and that learning and all forms of learning. So what exactly is learning? Learning implies learning about relationships. That is the most important thing you want to know about data science. Data science has machine learning. Learning here means you're just trying to learn about relationships between these attributes. That's what learning is all about. It involves taking a domain like a hospital domain or a business domain, understanding the entities and the attributes that represent the domain, collecting data about all of them, and understanding relationships between these attributes. This understanding relationships between these attributes is what learning is all about. So models is the outcome of learning. So what do you do after you learn about something is you build a model about it. Now this learning, when you're talking about here, learning happen all the time inside the human brain. We are consistently collecting data inside our human brain, continuously learning about things and continuously building models. And we use these models all the time without even our knowledge. Subconsciously, we are continuously learning about things. And what we're talking about here in terms of data science is this learning is kind of made into a proper process, and the learning happens outside the human brains in machines. That is what is a little difference between learning that happens inside the human brain and learning that happens with machines. There is a process to it, there is more data to it, and there is more a way of doing it. So what is a model? A model is a simplified, approximated representation of a real-world phenomenon. So there is a real-world phenomenon that is happening, and when you do a model, you're trying to first build a simplified model. You're not trying to put too many things into the model. You're just trying to take the most important things about the real-world phenomenon and then building a simplified representation or an approximated representation of the real-world phenomenon. You can actually go and build as complex models as you want to represent the whole thing, but usually when people build model, they want it to be simplified, so it brings out all the important factors you want to bother about and ignores everything that you don't want to bother about. So it's a simplified, approximated representation of a real world phenomenon. It captures the key attributes of the entities and their relationships. And let's say an example of a model could be a mathematical model. A mathematical model is something that represents the relationships like an equation. So you can write an equation that represents the relationship between the attributes. Like for example, you can come up with this is a formula I got from somewhere in the web. Here is a formula of how you can determine blood pressure. This is an equation. So a blood pressure equal to 56 plus the age of a patient into 0.8 plus weight of a patient into 0.14 plus LDL level of a patient into 0.009. So what you see here is you're trying to compute blood pressure from blood pressure is one attribute from three other attributes: age, weight, and LDL. Now this is an approximate computation of the blood pressure. It is never going to give you the accurate value at all, but it could be approximately close to the real world value. So here is a formula which represents a mathematical model of how a blood pressure can be related to three other attributes: weight, age, and LDL levels. There could be another model which is like a decision tree model. It is like a logical model where you ask a series of questions, and the series of questions that you ask, you include questions about various attributes, and then based on that come up with an outcome. Like you want to predict something like buying a music CD, and for the thought that you can come up with a decision model like this: if age of the customer is less than 25 and gender of the customer is male, buy Beyonce CD equal to yes. So you use two attributes, gender and age, and based on them you're trying to predict with the outcome, which is will the customer buy a Beyonce CD or not. So this is another type of models. Accuracy of models depend on the strength of relationships between the attributes. Sometimes the relationship between the attributes are very strong, such that you can predict like with 100% guarantee that, okay, if I see this, I'm definitely sure this is going to be the outcome. Sometimes the accuracy is not that much. So in that case, you might want to combine multiple attributes and see if you can increase the accuracy level. Sometimes there is no relationship at all. So it can be in any form, any kind of varying scale that you might get there. But model overall is a simplified, approximated representation of something that is happening in the real world.